Welcome back to Geometry Classroom. Today we'll start a new section. It's a big section called Area of Bidimensional Geometric Shapes or Figures. Because of the extension of this section, we'll split it into several smaller video lessons. For today, we'll talk about area of triangles. Yes, and next time we'll talk about area of quadrilaterals and circles, and then we'll continue with area of regular polygons. But for now, we have a few objectives. We identify, apply, and calculate the area of different 2D shapes, geometric shapes. First, we define the area of a geometric shape. The area of a geometric shape is the amount of space inside the boundary of 2D shapes or bidimensional shapes, like in these shapes, right? So, the amount of space that is enclosed by the boundary of each geometric shape is called area. Yeah, is what is inside the content, if we say of each shape. Now we start with area of a triangle. The area of a triangle is half one half the product of the base of the triangle and the height of the triangle. So we can write area of the triangle is half of, means division by 2, base times height. Now, what about base? Base of the triangle could be any side of the triangle, right? Any side of the triangle could be a base. Now, what about height? Height or altitude of a triangle is the segment or line segment that joins the vertex or a vertex of a triangle and its opposite side, right? But in order to be height or altitude, this line segment must be perpendicular to the side, right? For example, in this case, the base is this side, right? Height is the segment that joins the vertex that is opposite to this side and the side, right? And always this line segment, right, is perpendicular to the base, right? Perpendicular means the angle between the height and the base is 90 degrees, right? Now, regarding base, any side of the triangle could be a base, right? But for example, if we choose as a base this side, right, we have to find the height that is associated to that side, right? Remember, the height of the triangle is the line segment that joins the vertex opposite to the side and is perpendicular to that side. If we choose this side as a base, right, its height would be the line segment that joins this vertex, this side, right, with the side and is perpendicular to the side, right? This is another altitude or height, right? And is perpendicular to that side. we'll have an example, right, with area of a triangle. Good. Now, let's move on to another slide. For example, find the area of the following geometric figure. Now, remember, to find the area of this triangle, we have to apply the formula base times height over 2. In this case, the base, right, or the bottom side of the triangle is 8 centimeters, right? The height or the altitude of the triangle would be 5 centimeters. Why? Because this is the height. This is the line segment that joins the vertex opposite to the base with the base and is perpendicular to the base, right? So, to find the area, we simply plug it in. So, base is 8 centimeters times height is 5 divided by 2. Yes? Now, first we evaluate the numerator. 8 times 5 would be 40 divided by 2, right? 40 divided by 2 would be 20. Now the measure is square centimeters. You have to pay attention when you mention the measure, because of area is measured in square units. In this case, the unit is centimeters. Because it's centimeters, we say square centimeters. Good. Let's move on to another slide. Let's talk about area of an equilateral triangle. So we'll not prove this formula. We consider and we take it as it is, right? And the area of an equilateral triangle is square root of 3 over 4 times square of the length of the equilateral triangle, right? So, in other words, whenever you have an equilateral triangle and you know the length of each side, you apply this formula, right? It's easy. Now, let's have an example. In this example, the perimeter of an equilateral triangle is given, and also its height. But we don't need that height. Calculate the area of the triangle. Now, in order to find the area, you apply this formula, right? So, let's rewrite this formula. Equals square root of 3 over 4 times, let's say, times in the numerator a squared. Now, in order to be able to find the area, you need the value of a. To find the value of a, you have to use the perimeter of the triangle, which is given. As we know, the perimeter is the distance around it, right? Because an equilateral triangle has all of its sides congruent, we can say 9, which is the perimeter, would be a plus a, right? Is the distance around it. Now, we can say 9 equals, how many a's are? 3 a's, right? And we solve for a. we divide by 3 both sides, right? And we get 3 equals 8. In other words, the length of the side of the equilateral triangle equals 3. Now we know A, we just simply plug it in. So we can say area of the equilateral triangle would be square root of 3 times A is 3 over 4. And we can estimate, approximate this area using calculator, right? So we simply type. So first we press Control and divide. On top we press Control and x squared. Under the radical we type 3. Then we go outside the radical. We multiply by 3. And then in the bottom we divide by 4. And then we simply Control and enter. So we got 1.299. That can be approximate or round up to 1.3. In other words, the area of this equilateral triangle would be 1.3 again square centimeters. Good. And the last type of triangle we're gonna talk is area of a right triangle. When we have a right triangle, the area of a right triangle would be half of the product of the legs. It's easy this time, right? Why? Because the legs are perpendicular to each other. One of these legs would be the base, and the other leg would be the height. And it's easy, right? So let's have an example. Find the area of the right triangle below. In this case, as you can see, the hypotenuse of this right triangle is given. The legs are congruent, which means this right triangle is in the same time an isosceles triangle. Because it's an isosceles triangle, this triangle has two angles congruent. Because this angle is 90 degrees, automatically the other two are 45 degrees each. Right? So we deal with the special right triangles 45, 45, 90. Yes? A few weeks ago, yes, last year, we dealt with 45, 45, 90. Now, in order to find the area, right, we need the length of each leg, right? Because the area of a right triangle is leg 1 times leg 2 over 2. So, if we know the length of each leg, let's say leg 1, leg 2, you'll be able to find the area. Now, we know the hypotenuse is 8 square root of 2. We know the leg in a 45, 45, 90 right triangle, yes, leg, times square root of 2 would be equal to the length of hypotenuse. Right? We learn about properties or relationships between between leg and hypotenuse in a 45, 45, 90. Now, because both legs are the same, doesn't matter which leg is leg 1 or leg 2, right? Let's say leg 1. Yes? Now, the leg is unknown, right? We don't know. Let you know by x. You know by x, right? So we're gonna have x times square root of 2 equals the length of hypotenuse, which is 8 square root of 2. Yes? Then we solve for x. How we solve for x? By dividing by square root of 2 both sides. Yes? And we get simply x equals, we can divide out square root of 2 and square root of 2, and we get x equals 8. But x is leg 1, right? Which is in the same time leg 2. Because this triangle is an isosceles one, right? So we found both legs. We simply plug it in formula of area. So area would be leg 1 is 8, leg 2 is 8, divided by 2. 8 times 8 equals 64 over 2. Half of 64 would be 32. And now pay attention. Yeah, in this case we don't have any unit, but we can write unit square. That's the way of finding the area of triangles, right? Now, that's all we have for today. Next time we'll learn how to compute the area of quadrilaterals and circle. Thank you for watching my video.